Have you ever seen an application that worked perfectly for 10 users but completely broke down when 1000 users showed up? This is where scalability comes into play. Scalability is a system's ability to handle increased load, whether it's more users, more data, or more requests without compromising system performance. A today's startup can become tomorrow's unicorn overnight, and you do not want to redesign your entire system every time your traffic increases. Even if you are starting small, if your system isn't scalable, it won't survive the growth. A system can grow in many ways. It can be increased user base, new functionalities, and growth in data volume. Now let us understand few ways to design your system more scalable so that it should not crash when the load increases. The first and the simplest way is scale up, or also known as vertical scaling. In this, more power can be added in the current system by upgrading it with more RAM, CPU, or additional storage. It is simple to implement but has physical limit. We can add a limited amount of those resources to a server, and once that limit is reached, we can't scale the system any further. Another approach is scale out, also known as horizontal scaling. In this, instead of upgrading the existing machine, we add more machines to share the load. It's considered more effective for larger systems. The only drawback it has is it makes the system more complex, but it is unlimited. So you can add as many servers you want to distribute the load. Its complexity increases because we need to introduce few more components in the system like load balancers to make it work. Now, before we move any further, let's just compare both scaling approaches. From the complexity point of view, vertical scaling is very simple. So its complexity is very low as compared to horizontal scaling. For the cost point of view, vertical scaling is more expensive than horizontal scaling. Vertical scaling has a physical limitation. A server can be upgraded up to a certain point, which is not in the case of horizontal scaling. The downtime risk in case of vertical scaling is very high. It's kind of a single point of failure. But in case of horizontal scaling, due to redundancy, the downtime risk is very low. If a server crashes, the other servers can absorb the load of that crashed server, which makes the system more resilient. Now, other than these two approaches, there are few other things to consider while designing your system to make it more scalable. The first one is keeping your services stateless. Stateless means every request is a new request to the server and contains all the required information to process it. So server will not save any state or session for the user. Let's say the first request is served by instance 1, and when another request from the same user comes in, instance 1 was overloaded, so the load balancer redirects the second request to instance 2. Now, if the service is stateless, then instance 2 will be able to serve the request without any problem. But if service is not stateless, then instance 2 will not have any information on the requester like saved state or session. So the most basic setup to build a scalable system is designing your service a stateless service. Another point is optimal use of load balancers. So if you have opted for horizontal scaling, so the load balancer is already in the picture. It helps distribute the incoming traffic to multiple servers and prevents one server from being overloaded. To handle heavy load more effectively, you should consider adopting some kind of caching in the system. This will relieve the database from repeated same data requests and result in less network congestion. In addition to these, try to keep communication between services and external components loosely coupled. So design your services to process the request asynchronously. For that, you can use reactive framework or a middleware component like Kafka or RabbitMQ brokers. Cloud providers like AWS and GCP let you autoscale based on traffic. Autoscaling means automatically add new servers if load is more than the configured threshold and remove once the load normalizes. This ensures that the system can handle spikes of traffic without the manual intervention. Most of the time, we forget how a database can single-handedly destroy the entire system performance. No matter how many application instances you have in the system, if you have not designed your database to be scalable, then no one can help you. So plan for database sharding early. If you want to learn more about database sharding, you can check out the previous video in this playlist. Now, there is no hard and fast rule to select the type of scaling or any other component, but more servers is not always equals to better performance. Just throwing in more servers won't magically make your application faster. If your application isn't stateless or if your backend services don't scale independently, then more servers just sit idle and create more problems like race conditions, session issues, and data inconsistency. Scalability isn't a button you just press when traffic hits. It needs planning. And if you wait until your application starts crashing to think about scaling, you will face downtime and angry users. So be proactive, not reactive. Your system is only as fast as your slowest component. So if your database can't handle high load, it becomes the choke point, no matter how many servers you are adding to handle the requests. So optimize the bottlenecks before scaling everything else. So that's all about scaling in the system design. If you learned something new today, don't forget to like, share, and subscribe. Drop your questions or topics in the comments. I'll reply to everyone. In the next video, we will cover one of the most important concepts required while designing any system. We will cover cap theorem. Once again, thank you so much for watching. I'll see you in the next video. Till then, let's keep learning.